Hey, welcome back to the bench. Good to see you again. I hope you're all well. Thanks for joining the channel. So what do you do if you come across a vintage, 80s vintage CD player in its original packaging? Well, you buy it, of course. So I found this at a Goodwill, and yeah, it came with the original box, original styrofoam. So let me get this out of the box and let's have a look at it, see what we can do. Alright, here it is. It's an Akai CD-A305. I don't know, Akai made their entry into the CD player market just like everybody else. They were trying to capitalize on a trending movement. This is actually not bad. Optical direct amplifier laser pickup system. Well, I don't know what that means. It's got a display here, minutes, seconds, 5-function display, play, stop, and then we have search here and skip here, repeat, program, display, okay. Alright, it's a nice little player, it's tiny. March 1988 is a date code on there. It's got the non-removable RCA connector for an output, and then it's got a power, and that's it. So it's a budget unit, very minimal design. Let's plug this in. I happen to think it's going to be the typical tray belt doesn't want to work and the tray won't come out. A polarized plug. Let's plug it in. Turning it on. And we're greeted with a 0 in the vacuum fluorescent display. Let's try opening it. We've got, okay. So power is going up and down. I don't know if you noticed that. It's going down to 4 watts. Okay, it stopped. So it gave up. Let's try that again. See how it jumped up to 8 watts. Down, up and down, up and down. And then it gives up after a while. There, it gave up. So the motor is either the motor seized or the belt is, some mechanism's jammed. There's no sounds coming out of it, so it's a total silence. Usually you can hear a motor if it's struggling. If it's slipping, you can hear it for sure. But this has nothing, absolutely nothing. Sometimes you can coax it out. I don't know. Okay, let's pull the lid off. It's not working. This is sort of interesting here. We have kind of a puzzle. We have 2 screws marked off with arrows here. If you can see the arrows, they're stamped in the metal. It's pretty faint. And then we have this screw that's held in with a zip tie. I don't know what the purpose of this is. And then we have 3 holes here with no screws, marked off with arrows. So is this a transport thing? Like when you need to transport it, you put the screws in place? I'm not really sure. I guess I should read the manual. Okay, so after a bit of searching, I just found out it's very easy to find a service manual for this. Paid and free download, but I haven't found a owner's manual. In the service manual, it does mention 3 locations as being transport screws, and I think it's these 3 here. But this bottom of this unit looks entirely different from the photo they have in the service manual, so I don't know what to believe. I think these 3 here are our transport screws. I don't know what the other ones are. So I'm going to leave it at that. I don't know. Okay, let's have a look inside. Okay, lid's coming off. There we go. Looks nice and clean inside. Looks very clean. And what's going on here? Disc is clamped down. What's going on here? Wow, this is some janky stuff going on here. Look at this headphone thing on the side here. Well, they have a little amplifier for your headphone. Ground is, they couldn't even get the soldering right on the ground. Looks like they tried, but they didn't get it quite hot enough. So for a DAC, we have a Burr Brown. We have a Burr Brown PCM 56P. Alright, I don't see anything going on here. There's a motor here. This could be our tray loading motor. Let me plug it back in and we'll try. See if we can get something moving here. It's powered on. I wonder. Let me check for voltage across this motor. Maybe our motor is done. Okay, so there, I'm going to press the button. 3.7 volts. And then it stops. So that motor is not turning at 3.7 volts. We might have a problem with that motor. Let's I'd like to pull that motor out and just give it a service. Maybe it's just seized up with dried lubricant. Don't know. But it looks like it just snaps in place there. Alright, I need to get this transport out to get underneath it. And I think I have to remove the faceplate. So give me some time. I'm going to do some disassembly here and then I'll bring you back in. Alright, 5 screws removed, 3 on the bottom, 1 on each side, and our panel is free. We need to unplug this headphone amplifier. And we have front panel connections. We have the ground screw. Let's get this ground screw out of here. Okay, ground is free. These connectors here, you release them by pressing down and then lifting up on the wire. Pressing down, lifting on the wire, and then we're free. Soldering on this isn't the greatest. I'm gonna say it needs some good scrutiny and then maybe a cleaning up. But we'll deal with this in a bit. Let's get after this motor first. Now, pull this out. This should just lift right off. There we go. Okay, we got 1 screw here, 1 screw here. Let's pull this one out. Wow, what is going on here? It's in crooked and it's seized. I think somebody might have had this apart. And they cross-threaded it when they put it together and it does not want to come out. Yeah, what the hell? There we go. It's got a shoulder on it. I think this was cross-threaded. It's a machine thread, but okay, so we need to get this. There's no access for this screw because the tray's closed. And how do you open the tray? It's locked in place. So let me figure this puzzle out and I'll bring you back. Pretty sure these screws got to come out. They don't serve any purpose other than to. I wish they'd make up their mind if they want the screws from the top or from the bottom. This is kind of silly, this design. Got 2 screws in the bottom. transport screws. And then we got one from the top down, which I can't access, but maybe I can now. So rubber feet. Now I can open the tray now. There we go. There. That's what they needed. Okay, let's get this out of here. This, and this. And let's remove our last screw. Okay, now we're in. And another ground. All right. So the motor is spinning. I wonder if I just freed it up. Let me try taking this off. It's not seized. Let's put power to this. Where's the green wires going? I have to okay, green wires are coming out here, so we are okay to put power. We're not going to feed power back into the board. That's something you want to really avoid. So let's put this here, let's feed power. Let's go with 5 volts. It's working. Working. Okay, let's turn this down to 3.7, 3.5. Still working. Let's put the belt on. This belt seems okay. All right. I think the motor was just seized from lack of use. So let's try this. Working now. I think you saw that. Let's work it a few more times. Yeah, whatever is just stuck, I think. Alright. Let's, since we got it all out and apart, let's service have a look at the laser, clean it if necessary. I still want to lubricate this motor. Take this out and let's see here. This is our sled motor. These rubber cups here have to go, yeah, I think they go in these posts, so we'll have to put those back. Alright, well, let's take this motor out and lubricate it. I'll just lubricate it in place. So I added a drop to the shaft of this motor and it made it quite a bit quieter. Let it spin for a while. I think it just had a flat spot on the commutator and that's why it wasn't starting up, but it's working now. Now I'll do this motor. I'll take this one out, remove this screw, lubricate this, and let it run for about 5 minutes. These motors, they need to get out and exercise them once in a while. You can't just let them sit, and then they do a limited amount of work. Like this one opens and closes the tray, but it only works for a few seconds and then it shuts off. So it doesn't really get a chance to clean itself when it operates. So I removed this motor, and this was stuck at first, and now I moved it, it freed itself up. I'm just going to give it a little bit of silicone grease on the slide. This side here as well, I guess. Just exercise that, get it worked in. It's looking pretty good. Same goes for this motor. I added a drop to the bearing, and I'm just going to feed it with, well, I got 3.5 volts here. Let's just put this on. Just going to let this spin for a while. It's silent. Okay, with the tray out, let's remove this disc clamp. There's a clip here on this side. This side, the disc clamp is sitting in a slot. This side is clipped in, so if I can push the clip back, I can lift this side. Don't push too hard, or you snap the. It's just plastic, right? So if you press it too hard, you'll snap the piece off, and then you'll be trying to figure out how to glue it back on. There we go, just enough. And then there's a spring on this post here that fits here. That's a disc clamp spring, and here's our disc clamp. Put this aside. I have to clean this surface. The surface gets dirty, it picks up dust. It's rubber, it's supposed to grip the disc. And look at this pickup, it's pretty fuzzy. Let me zoom in on it. I'm hoping you can see this. There's fuzz sticking out from the, like it's growing a mold or something, but it's not, it's just dust. Just going to wipe it with a dry Q-tip. Just going to remove the dust. I don't want to use any liquids on this, because liquid could dry and leave a stain behind. That actually looks a lot better. Yeah, I'll hit it with a little bit with compressed air. And this thing here, and for the disc clamp, I'm going to use alcohol. Just clean all that crap off. See how it's. That's pretty good there. Get rid of all that dust. And there's a limit switch here. I just want to connect my heater to it and see what kind of contact resistance we have. Alright, so let's close it. We get about 1/2 ohm. Oops. Yeah, we're getting about, well, we're getting about 2 or 3 ohms, but sometimes it goes down. So I'm going to clean this switch here. Pretty easy. I can remove the screw, lift it out, and use some abrasive paper. Just going to use regular paper, regular white paper. Just going to put it in here first. And then I'm going to spray it with some 401B. And then I'm going to work. Close the contacts and work this. This should remove all the oxides. Okay, let's test it one more time. What do we got for resistance now? Okay, that's a lot better. We got about 18 milliohms. 20 milliohms, that's perfect. Put that switch back. I think it went right here. So let's put the screw in. Okay, all done. You can take the tray out for a wash. Let's take the tray out, and it's locked in right here. There is a catch. Just pull that tab back and let the tray go past. Yeah, that side's good. This side isn't. Come on. There we go. This gear is jamming, that's the problem. Alright, I'll clean this, bring you back. It was jamming here on this gear. There's another limit switch. You should check that one as well. Yeah, the switch here we're getting about 1 ohm contact resistance. I'll remove this switch and clean it as well. Okay, tray back in, but we have to watch out this switch here. There's a lever sticking up, and if you just shove the tray back on, it's going to lift. So I think the solution is position this gear all the way out, drop this side in, and then where's our out position? I think we just need to snap it down into place like that. Let's pull it this way. There we go. And this side's in, both sides are in. Alright, so taking the tray out opens a big can of worms for getting it back together and having it aligned properly. This is the fully extended, this is the fully loaded position, and this gear here is important, alignment of that gear. So you put it in the fully closed position, okay, and if you're having troubles, just remove this large gear, this cam gear. Once it's in the fully loaded position, you should be able to take a screwdriver and stick it through this hole, and it should lock it. Okay? And then you have this here, which is sliding. That fits in this groove here, and this point. This cam follower follows in this cam. So if you can get that located and dropped it into place. Come on. Why is it being held up? Okay. We're not quite there yet. Last thing you need to do is line up these two marks. So like it here, I'll show you if you can see that. Let me put a little mark on these. There's little nubs sticking up that you can hardly see. I'll put black ink on them, and then you can see them a lot better. So these two need to be aligned, and right now they're not. Okay, so we need to lift this gear and give it a bit of a rotate, and it should drop in there. Now they're aligned. And then you put your C-clip on, E-clip, whatever you want to call it. And you got grease and sticky fingers. Okay. There. Alright, we are good. So that should work now. Now that it's back together, just check its operation a few times. Just make sure it's not binding. See, there's binding again. It's hitting back here because we're missing the disc clamp. Okay, everything's good. Alright, spring Spring goes there. Hook this side first. This goes under, I believe. Hook this side. And then this other side snaps in. And then we should be good. Alright. If I manipulate the gear, this clamp should come down. And it does. So it's all working. This has to be on top. The CD drives back in place, so let me take this apart. I'm going to do some cleaning. I'm going to look at all these connections. If there's any bad, I'm going to resolder, clean this, and then we'll put this back on, then we'll do tests. Okay, everything's fine on this board. I didn't find any cracks. Everything looks good. Cleaned it up. This can all go back. This, on the other hand, looks good too. I can put this back as well. So I'll put this back and we'll assemble the front. Alright, we're back together. Hopefully for the last time. Let's plug this in. Turn on the power. Looks like it's working. So, perfect. Alright, let's load a disc. Let me get an amplifier going and we'll load a disc as well. So, for today's testing is two-door Cinema Club. And we're going to try this one out. Let's see. Play. Ooh. E. It says E. Let's hit play again. Makes a lot of noise. E. Error. So it's having a real hard time reading discs. This disc is actually not bad condition for a library disc. Yeah, it just refuses to play. Hang on. No, it just about played. Let's try a different song. Let's try song 2. Let's try song 3. If you can't see the display, let me show you this display here. So I hit play. Does not like it. Let's try a different disc. Let's try my diagnostic test CD. Yeah, it refuses to play. Alright, so I need to put this into test mode to do certain tests and adjustments. And to do that I need to short J304, the pins on J304. You can see it here. But nobody put pins here at the factory, it's blank. So I have to pull the main board out, install some pins, and then I can short those two out. Probably could short it out now, but I don't want to. I'll just pull the board, put pins in, and I'll be done with it. And then you take your measurements off this connector here. You can connect your scope up, and we can adjust the focus servo, the tracking servo, all that cool stuff. So let me get this main board out, get some pins installed, and then see what we can do here. Alright, so I flipped this board over to install test pins, and I see something very interesting. About 7 pins here on the end of this chip are all cracked. And it looks like when I went through the wave soldering, the solder was very thin in this one corner, but I can definitely see cracks on 1, 2, 3, 4, 5, at least 7 pins here. These all other ones look okay. But I'm going to scrutinize this board, and I'm going to fix this up, and then scrutinize this board, and then figure out if there's any other problems I'm missing at. It could be something simple like that. Okay, like it says in the manual, to turn the test mode on, you have to short jumper 304, and then turn the power switch on, and then confirm that the fluorescent display says 0 and test, like it does there in the top line. And then when you press the play button, you're going to cycle through all the different test modes. So we want test mode 4. Let's do that. You just short this out with a screwdriver. And you turn it on. Okay. And it should say 0 test. Okay, so we cycle through 4. We'll hit 4. So I set the focus servo control gain. Turn it on now. Loads a disk. Hit play. Still having troubles. It read the table of contents. Let's try. I'm wondering if that sled is even moving. I don't even know if it is. I'm going to have to confirm that, because Sled. There's one chip here that's getting really hot. It is a STA341M. It's getting really hot. I wonder, oh, maybe that's a problem. Let me confirm that the sled is even actually moving. Okay, here's a sled motor. They call it slide motor, but it's sled motor or whatever. So this is the motor that positions the pickup optical block. And it is driven, well, it's between ground, and it is driven by this line, which goes to pin 6 of this STA341M. This chip is getting very hot, and as far as I can see, it's just complementary transistors to push-pull this line, positive or negative, depending which way that they want the motor to go. So pin 6 should be near 0, unless it's trying to move. And if it's trying to move, it's stuck in one position. I should be able to tell. And our drive for this is pin 4. And then we have pins 1 and 5 is our positive and negative. We've got positive, negative 7.1 volts. That's where our rails. And then this is like a little amplifier, but it's actually just motor control. So we got 3 of these. And I'm going to see pin 6. We're going to do some tests on pin 6. Alright, so pin 3 should be the pin that I'm after. Okay, let's turn this on. And I hope you can read this. Let's turn this on. Alright, hit play. Yeah, we're getting 2.8 volts. It's trying to move the sled, but the sled's not moving. It's sending voltage out, a positive voltage, and that motor is either jammed or it's stuck. So let's have another look at this. I can also see the sled switch here is jammed to the max here. It's pushed as far as it can go. You can see how it's bent, and that tells me something is up. Okay, this motor is jammed. It is pushed. I can't turn it anymore. I can turn it off. It's jammed up against this way. You can see if I push it backwards. But if I move it this way, it's as far as it goes. Now, why is that motor being told to move that way? Maybe the limit switch is not giving a signal that it's at the end. So where's my limit switch? I need to pull this out. Here's our switch right here. It's maxed. So let's get a reading on this. could be that that STA chip is bad and we got a shorted transistor. So let's see what we have here. We got a closed circuit. So the switch is telling the controller that it's closed and stop pushing. That's what it's actually telling it. Stop pushing. But that message isn't getting through. Or maybe it is. Maybe the message of stop pushing got through, but the transistor's latched on. That STA transistor, we might have to pull that out and check it for shorts. And if that's the case, we might have to rig up something else. Let's back this off a bit. Pull that motor back, or that optical block back a good amount. Alright, let's put this back in and try it again. I have a feeling it's just going to go, we might have to pull out the disc clamp, I'm wondering. Okay, so we know that this limit switch here is doing its job. When this sled hits the stop, the switch closes, sending signal back to the controller. But for whatever reason, something's telling this motor here, just to keep pushing. And it keeps, we measured it was 2.7 volts on it or whatever it was. So what I think it is, I think it might be this STA chip. So I removed it. And it's just 6 transistors, and they're arranged in push-pull. So we should be able to test this easy to see if we have a shorted transistor. Let's go into diode mode. And let's check pin 1 and pin 5 of our supply lines. So let's go pin 1 to pin, let's check 4 first. 1, 2, 3, 4. It's open. And then check pin 5. That's open. 1, 2, 3, 4, 5, 6. 6, okay. 1, 2, 3, 4, 5. And pin 6. We had a bit of a reading there between pin 5 and pin 6. So from pin 1 to pin 6, you get nothing. Okay. So between base, pin 4, and pin 1 and 5. Okay, so we should have transistor there. Pin 4. Oh, pin 4 and pin 5. Okay, there's our transistor. There's our other transistor. Seems to be working. This seems to be working. And this is the one that is a sled motor. So it goes, this pin here goes directly to pin 6. Pin 6 also goes, oh, this is a feedback. Okay, so this is feedback here. This is our output. We could measure pin 19 to see if it's outputting, what kind of signal it's outputting to turn this transistor on. But for all purposes, this thing, I'm going to check these other, I wonder why this got so hot though. That's working. So this chip is okay. Test's okay. I don't see any problem with any of these 6 transistors. If there was a short, we would be getting the full power supply of 7 volts, minus 7 volts on the emitters, pin 6. Let's just look at this board here, and I can't really flip it over. You see these 2 caps here, right beside this chip, the driver chip. So we got 2 caps here. They're 220 at 16 volts. I'm going to test these caps. Let's test them. So, I got a new toy. I think it's kind of cool. So let's just try this. And let's try this out on this. You can't see it here, so let's do this. So what's this one say? 95 microfarad. This is a 220. It should be reading 220, not 95. So let's look at this one. And I have to move the thing up so you can see it. So here we go. If I can get a connection. This one reads 41 microfarad. 3.5 ohms ESR. Maybe we just got bad caps here. Maybe that's what's going on. Let me check a few more. Where else can we find some? Here's one. Right here, this is a 220 at 16 or 6.3. That one reads 469. That's supposed to be a 220. Maybe it's in parallel with something else. Where else can we find one here? This one here is 100. And it's reading resistance. Okay, that's not cool. Let's try this one here. Let's try this one here. This one's in the heat zone too. This is a 50 volt 10 microfarad. And that should be right here. 10 microfarad to 50 volts. So we're getting 8.8 on that one. But these ones are bad for sure. This one should be 220 and it's reading 90, 91. And this one's reading less even. So let's pull those caps out and replace them. So we definitely have bad caps here. This is supposed to be 220 at 16 volts and it's measuring 71 plus 2.2 ohms ESR, which ain't cool. And the other one measures pretty close to the same thing. Let's see here. This is the other cap, 90 at 1.7 and 1.8 ohms ESR. I'm going to pop two new caps in here. I don't know if that's going to fix it, but it's going to make things better. Alright, we're back together again, just enough to test. So let's put a disc in. Let's plug this thing in and try it. Okay, here we go. Ooh, took a while. Okay, read the table of contents. Let's hit play. It's playing. Look at that. Wow. Let's get some audio for you. Plugging in the amp. We've got no audio. It is playing because we can see it on the display here. It's kind of dim, but it's playing. Made it skip. Got no audio. What's going on with that? Power's on. Okay, the amp is working. CD tape. I'm getting any output. No output on the output. Okay, we're getting signal up to this point. So everything from here back is working. There's nothing coming out of the DAC maybe. I'm checking the DAC here and there's nothing Okay, so we still got problems, but we got it playing, and it seems to be. Let me try a different song. It's working. For whatever reason, we're getting nothing out of that DAC. So, let me put my thinking cap on. Okay, here's a look at the audio output circuit. Here we got our line out, left channel, right channel on this side. And it looks like we have two muting transistors here because they are connected between the output line and ground. That's typically what a muting transistor does, is it shorts the signal to ground when the transistor's turned on. But you know what, I don't think these two transistors are being muted right now because I was touching around here with my finger on all these chips, this chip, and I was getting my signal from the hum from my body getting transferred through into the amplifiers. So this is not muted. I don't think it is, but I can confirm that by checking if there's any signal on these transistors. Now it should say negative 6.1 volts on the base. That should keep the transistor turned off. And then when they want to mute it, whatever signal comes in and turns these transistors on, and then these transistors shunt the signal to ground. But like I said, I don't think that's our problem. Two op amps here. These are 5221s, 5218. We can check and see if signals flowing through these. I think they are because I was touching around this chip. This is the 4052, and it looks like it's a dual switch of some kind. It's got switching going on in here. So this might be open. This might be where our signal stops. Here's our DAC. So all the data comes in here, shift register latch, and then this is our 16-bit DAC. So coming out this side should be our audio signal. It'll be a raw signal full of switch noise and everything, and then that's the purpose of the low-pass filter, is to get rid of all that high energy, high harmonics switching noise. So I can poke around here on this side, chip IC706. I can poke around on this side of the chip for any audio signals coming out. Looks like 11, 12, and 13 is a ground. Pin 16 is a VCC, so that's not. So the only output here is on pin 9 and 10. Vout RFB. And what does this thing do? Does it chop left and right signal out of the stream? I'm thinking that's what it does. Chops your left and right signal out of this, does it at high speed, and then it sends it to these amplifiers and filters to get rid of all the hash, and then it sends it out the back. That's what I'm guessing here. So our signal should be on 9 and 10. That's what I would check for our output, our audio output. Okay, at this point I'm beginning to believe we have two things going on here at once. We got bad caps, which approved by replacing these two, and then all of a sudden we're now able to read the data stream, and it's coming through on the clock. It's counting, but for some odd reason we're not getting any audio. Haven't figured that one out yet. So two problems. We got bad caps in this thing. Another problem is it needs an alignment. I'm pretty sure somebody was in here with a screwdriver dicking around and tweaking things, maybe trying to, in an attempt to improve it. So what I propose to do is replace some or all of the caps. I know there's caps on this board too. Be careful what I touch here. I'm plugged in. It's unplugged now. So these caps might need to go. Some of these power supply caps might need to go. Some of the caps around by the digital analog converter might need to go. These two caps in the servo outputs, they were gone. So maybe there's like more stuff here lurking that I don't know. And then go through and we'll do a complete alignment. And I think that should bring this thing back in. As far as the no audio, I'm not really 100% sure. We're going to see if we have audio coming out of the DAC, and then it goes into this chopper. I think that's a chopper, and then it goes through these op amps and these filter networks. So yeah, the no audio thing is kind of puzzling to me, but I think, like what I said, I think the first step here is to put some new caps in this thing. I don't want to replace them all, but I can definitely pick out some of the worst ones and replace some of those. So let me get started on that. Alright, update time. So I pulled out 4 dead caps. They're failed. Okay, these ones failed. They're no longer close to their value. And then I just pulled out a 5th one. This is another, well, it's 5 failed caps. So this one's failed in short circuit. So this one was in, let's see, this one was position C809, I believe. And this might be the cause of my no audio on the output. I don't know what C809 does, but you can see here on the tester it's connected. This is a 100 microfarad at 10 volt cap, and it's measuring 3700 microfarad. Well, it's showing as a short, dead short. If I checked it with an ohm meter, it would be shorted. And 649 milliohms ESR, which is false as well. That's probably the resistance. If I check resistance, that's what we're getting for resistance across this capacitor. 649 milliohms. Yeah, so the caps in this thing are garbage, and they all got to come out. And I'm glad I made that decision, because finding a lot of scary things in there. This cap here, C803, was shorted. It's 100 microfarad at 10 volts. And I think previously I gave you the wrong part number, but this is the one that was shorted. This one is in the positive 6 volt regulator, so that filters noise on this Zener diode. If this cap's shorted, this is grounding the base, which would turn off the plus 6 volt supply. And this is a positive negative 6 volt supply. And oh, look what it powers. If I follow the lines down, it powers the DAC and everything else here in this area that's doing the audio conversion. So that would explain why I had no audio. I was missing a voltage there. Okay, finished the recap, and I gotta say that was necessary. Whoever built this pile of junk put a lot of garbage components in, like capacitors, the cheap Chinese no-name brands, and a lot of them failed. What do we have here? We have, for failures, 1, 2, 3, 4, 5, 6, 7, 8, about 10 caps that failed. These ones are all weak and dying. These ones all failed. So yeah, this was very necessary, and I'm glad I did it now. So I'm looking at putting it together. I'm hoping it's going to work with the audio. I think we have our audio back now that I found that shorted capacitor in the power supply. Another thing, sometimes I see this and I don't like it. They have this fuse here, and it's jumpered out with a piece of wire. They say 200 milliamps. I'm going to remove this jumper and install a fuse. I got them here. These are 500 milliamps. I don't have 200 milliamps, but 500 is better than a jumper, a piece of wire. So I'll put this fuse in here, and replace this, and get everything connected back up, and we'll do a test. Alright, ready to do initial power up, I believe. Let's turn on my amplifier and hit the power. Oh, Did you hear how fast that spun up and read the table of contents? It was just like bang. So our open close works, and it reads. It's going to play. I just know it will. It's working really good now. Ocean blue. Has no problem seeking and finding tracks. Sounds good. That's exactly what this needed, was a recap. I don't think it needs alignment at all. Doesn't have any troubles. Yeah, that's good. I'm happy with this. Trying to get a line on who made this thing. It says designed by Akai Electric Company Limited, Tokyo, Japan. Model number, made in Taiwan. Okay, so that explains all the garbage caps they put in it. Still don't know. If I look over here, it said manufactured LLE, so there's their manufacturer code. So there's the entity that manufactured this thing, but yeah. Alright, here's a look at the parts that went into this. So this is all the caps I put in. These ones have all failed. These are failures. These are the caps that haven't failed, but they're not the greatest shape. Some of them are getting pretty weak. This one's shorted, completely shorted. This is the one that knocked out the audio on the output stages. And then the rest of these are way down, like this 220, for example, measures down around 70 microfarad. So they're all drying out. Here is a baud resistor I removed and replaced it with a chip resistor, just to clean up the bottom of the board. So this is one of those not so rare cases of if you just replace all the caps, you end up fixing the machine. And that's what would have happened in this case. Replaced all the caps, the machine would have just started working again. And then you'd be wondering, well, what was wrong with it that, you know, that it wouldn't work? Well, we had noisy power supplies and we had a shorted power supply. So that's basically what takes these players down, is all that noise in the power and all that stuff. It really messes up with the servos and all the logic. That's why it's important to have good caps in your equipment. So, enough of me rambling. Well, there you go. It's another 80s CD player rescued from the e-waste end game. Yeah, that's surprising. I didn't think bad caps would mess it up that bad, but you know, that's what it is. It is what it is. I just was expecting just, you know, start the video, oh, the belt is slipping, yeah, put a new belt in, okay, we're done. But this turned out to be a little more interesting than I first thought. So yeah, I enjoyed repairing this, and I learned a few more things about CD players. So take care, and hope to see you on the next one. Thanks for watching.